give yourself space, and you don't want to pull a muscle doing a hobby. Fun fact, physio is probably more expensive than the panel you're trying to install. What's happening, guys? Scott from A Hornet's Nest. Welcome back to episode 30 of Tutorial Tuesday. As always, so good to see you. I hope you've been well. I hope you've got some sim building in. We are approaching Christmas. I love Christmas. Not only do I love the meaning behind Christmas, but I love that Christmas allows me to spend things online and nobody questions all the parcels coming in the post. Because I just tell them, hey, it could be a gift for you, but guess what? It's not. It's a gift for your boy. I've got some pretty cool things coming in the post. I've got the linear track actuator for the rudder pedals. I've got USB hubs coming in. I've got all the USB cabling coming in from the States. And I've got some things for the UIP as well. So parcels are coming in for me. I haven't done any Christmas shopping. I probably should do that. But hey, the cockpit needs to be built. And today we are finishing the lower instrument panel. So let's get into it. I want to show you two modules. You've seen the IFEI before, but I want to show you how we made the jet select panel, and that's going to finish off this section. And then we are going into the ECM and dispensing module. And that is all of our dispensing types, our RWR. I'm going to show you the back wiring as well because it looks sick. So yeah, let's get into it. We are coming towards the close of the series of Tutorial Tuesday building the F-18. We've got about 6 to 7 episodes to go. We're at episode 30. I've shown you how to paint, putty, prime, surface prep 3D printed parts, how to cut the MDF or how to get someone else to cut the MDF, how to prep that, how to assemble it, how to wire, and a little bit of coding. So right now we're just gonna motor through this and finish this off. So I'm gonna show you how I did the jet select, I'm gonna show you the ECM, I'm gonna show you something I did with the vid control panel as well. That's a little bit different to Open Hornet. So let's get into it. The first thing we're looking at is what I like to call the IFEI module, but it's really the left lower instrument panel module. And it contains the IFEI, the vid control, and the jet select. This IFEI panel here, I've done a little bit of wiring. So let's show you what I did at the station. And the first thing we need to do is get rid of the multicolored wiring. Yeah, it had some method to the madness. I used to multicolor wire because red would be 5 volts, black would be ground, yellow would be analog, and blue and green would be some sort of data or extra switches, right? And then I saw what white looked like. And if I just show you this, looks sick, right? I'm not saying that the color wiring doesn't look cool. I just prefer the white. So I've gone and gutted that all out, and I'm going to go and make some amendments to the vid control. And I'll show you this here. If we look at the interconnect quickly, this is page 3 of the interconnect, and it's the lower instrument panel. And we are looking at the area that talks about this left lower module. We've got the vid control, and there's IFEI, and there's all that connected. This wiring loom that we see here, on the left are our 2 connectors that plug into the ALE. We've got a connector up here, P5, which goes to your jet select. P6 goes to your IFEI control. And then P7, which is a special type of connector. It's not your usual M20s, which are your black header pins. We're looking at SMP, and it would have a reciprocal SMR. SMP, SMR, they are SM series JST connectors. Nothing special, but they are quite cool. I'll show you here. They're these here. You can get them in what would be 06V, which is how many pins it's got, and BC just means black color, which are these two. You can get these white ones or neutral, and it will just have N instead of a B. So you can get 2 different colors, they do the same job. That's if you're ever wondering if the black's out of stock, you can use white ones, it doesn't matter. But this is calling for a 6-pin connector going to connect the 3 video controls, and it all goes into one connector, allowing it to be disconnected from the loom, which is nice. But what I found out was we're tying it at the back of our vid control, and I can't get that vid control out easily without disconnecting that connector all up. So what I'm gonna do is I'm gonna apply 3 separate SMR SMP connectors, 1 for each of the switches and pots on the vid control, allowing me to create that vid control completely modular. Yes, not per Open Hornet spec, but hey, I find it a little bit easier and not messing up that back end wiring. We want this to be modular. We want it to be as easily accessible. Now, an easy way to remember these connector types, you've got the SMR and you've got the SMP. You've got the SMR, which is the receptacle, and you've got the SMP, which is the plug. Think about it that way. That's how I remember them best. And they've got their own little terminals, little crimps. So have a look at that. They're gonna be your best friend. And I've used a couple of them later on, which I'll show you. But now that's done. We're back to a clean slate of where we were. I just wanted to get rid of that color wiring. I want to progress with white. Let's get into the Jet Select panel. It was a pretty fun panel to build. It's just really repetitive. So if we look here, we've got 5 of these 0.55 inch square push buttons or Korry switches. And then we've got about 6 of these annunciator lights that are for the nose, left, right gear indication. And then we've got the flap annunciators as well. It's just a repetitive panel. Like if you're gonna do this, can I recommend just find all the 0.55 inch square push buttons and do them all at once. Get the Jet Select out, get the RWR, get your master cautions, get it all out the way now. It's a tedious process, but if you just do it repetitively and create a production line, it's gonna make it a lot easier. Now, a little bit of method and modifications for these that I made. The structure that you see, that is the panel itself, is just PETG printed on the QIDI +4. Great printer, great build space. You're gonna see future projects I'm doing with it. It's really nice. Yeah, there are similar printers now coming in the market. Definitely do your research. But if you're looking for something that's just reliable, and hey, it's my only printer. I've got 2 printers there. I've got the Creality V2 for the Ender V2, and I've got a Neptune 4. I haven't used them in so long. I need to sell them because they're taking up space, and I've got another cool thing coming in the post that somebody thinks is a Christmas present for them, but it's not. It's for me. So yeah, QIDI +4, really great printer. PETG, right? It's flexible, it's strong, it's resistant, it's a good plastic to print with. But then all of our push buttons and all of our fine detail work, that's done on my Saturn II resin printer by Lego. I'm using an ABS-like 3+ resin from Lego, and it's just great. Really nice resin to print with. I'm getting good results out of that. And then all of our lenses or our legends are made out of 1mm acrylic. If you're following the Open Hornet design verbatim, you'll see that it actually calls for the legend, or where the text is on, as a 0.03 inch little thin film piece of plastic, and then it's got an acrylic lens on top, which makes up 1mm. I found that with my laser cutter really hard, and then I found out in the process as well, Open Hornet actually intended that 0.03 inch plastic to be laser printed on, like just with an inkjet printer. So I tried the 0.3 lasering it. I didn't get the results I wanted. I think my laser's just too strong. If you had a diode laser that doesn't attack clear or white acrylic, you might get better results. But hey, I've gone to 1mm acrylic, I've back painted it, and then I've gone and back engraved it. So all that text is flipped. So when we're actually looking at this lens or the legend in the correct sense, all the text is the right way. Now you'll see that I've got white text on the center LIRI areas, and then it goes into a smoky color in the illuminating areas as well. I've gone and done the smoky color with Tamiya Smoke. It's just an acrylic paint. 2 coats of that, you're gonna get a really nice color. And it also helps kind of settle down that engraving cloudiness you see on clear acrylic when you're engraving it with the CO2. And then with the white, I've gone and used Citadel white paint. It's one of their base colors. I find Citadel is a really nice range for having high pigment count to the amount of paint you're putting down. That way it's just 1 coat over the top and you're good to go. That way light can still shine through it. I also, before I went to Citadel back painting it white, I thought, let me give creating water slide decals, decals, water slide stickers, whatever you want to call them, wherever you're from, a go. Now, it's not a bad option, and I'll upload this PDF so you can go print it as well if you want to send it off to a water slide manufacturer like I did. It's not a bad way if you don't have access to a laser engraver or a CNC engraver, and you just want that nice white enunciation. You're not looking for the illuminating triangles or anything. You just want something nice and white. Have a look at water slide stickers. They're not a bad option to go with. Now, if we look at the sheet that we've cut this on as 1mm acrylic, you'll notice that all my square lenses or legend plates are still on the sheet. So I've used tabs. It's easier for me to handle, it's easier for me to paint on. And then when I'm ready to cut them out, I just grab a scalpel, cut the little tab off, trim it down, and we are good to go. And we are ready to assemble. So the first thing we're gonna do is we're gonna grab the body or the mounting base of these square push buttons, and we're gonna insert these diffusers. Now these are again made out of 1mm clear acrylic with a very light misty coat of white paint on them. They're gonna diffuse that LED, creating a nice soft even illumination of the text. Once we push the two diffusers in, we're going to install the legend or the text into the bezel, which is the little mounting bracket here. And then we're going to sandwich it together, and there we go. We have created our first Korry switch. Now what I like to do is do this for all of them. That way you're just doing the pane once, you're not spreading this over multiple days. And then I'm going to dab a little bit of CA glue on the edges, on the left and right edges, because I'm going to lock it in. Sometimes the fit might not be right. Sometimes the fit is good, but then your finger's a bit sticky. So then it's going to pull that switch off. Lock it in with a dab of CA glue. Don't do the whole perimeter, just a dab. Because that way, if you need to fix it, you can just crack that CA dab and you're going to be able to replace your lens without needing to make it all over again. And then it's time, once that's all done, let's start assembling the product. We're going to start inserting the Korry switches and the enunciators in, remembering to get them the right way around, turn it over multiple times to double check. And if you are confused of their orientation, instead of pulling DCS up on the PCB itself, you can go and just have a look where the orientation is there. Open Hornet has done a great job of silk screening that data as well. And then we're going to clamp it all together, screw it in, and we are all good to go. Can I suggest, if you're not doing this for decorative purposes and you're not trying to create an Instagram post the moment you make it, or you're not filming a YouTube channel, leave the jet select out. The reason is, if you see here, I'm pushing on the back of the screw that connects it to the panel or the structure. It actually fouls these screws, and that's fine. They countersunk and all that, but you just don't have to screw it in, unscrew it just to install this big panel. So if you're going to install it straight away and you're not testing backlighting or anything, leave the jet select out, or at least just leave it loose and then you can work around that. And then we go and we put all the wiring, and we've created all the ABSIS cabling, and you can see how lovely that white looks, and you can see how nice these little SMR connectors are, creating a nice seamless product. Now, before we move into the ECM panel, let me give credit where credit is due, and that is thanks to PCBWay. As you know, PCBWay is the channel sponsor. They provide me with all my circuit boards, they provide me with any CNC milling that I can't do myself, any 3D printing that is just too large for my printer. Now, where are they on the bell curve? They're in the middle. They're not the cheapest, they're not the most expensive, but that's okay, because I've never had an issue and I've always loved their quality and their response time and their service. Now, the thing with PCBWay is not only are they doing the circuit boards, but if you don't have a 3D printer or you're not ready to invest in one, you just outsource it for a fraction of the cost. Now, no better way to start with PCBWay's big Christmas sale. Massive coupons have been prepared, first come, first serve, get in quick, save up to 50% off, enjoy free upgrades on PCB colors, including purple, matte black, and pink if you really want to go there, and 10% off 3D printing materials. If you're looking for 3D prints, PCBs at high quality and a good response time, go check out PCBWay. Now, this lower instrument panel is made up of the actual ECM structure. We've got the RWR, the cabin press, and then we've got a random little cover which a clock could have gone to. Now let's look at the RWR first, because we've just come off making Korrys. Let's keep punching on with the pain of Korrys. This here is no different. What you will see though is that we've got very similar to the Jet Select, where center LIRO was white. We've got ALR 67 power is white. Now, if you look at the Open Hornet Fusion, it shows that it is black behind that. I don't think they're intending that to be backlit, but there is an LED there. So I've left it. I've gone and still done the usual white and smoke, but I haven't blacked out that diffuser panel. I've left them both a diffused white. That way I can get backlighting through it. I think it looks nicer. But hey, correct me if I'm wrong. If we are, we're just gonna fix it. And yeah, nothing's different. I have seen some people paint their lenses almost like a matte. It gives it a bit of a anti-glare look. I like that. I think I'm gonna go do that after this. I don't like seeing fingerprints, but hey, that's a later job. Let's get this cockpit finished, then we can tweak. ECM was a nice panel to build because we did the pain of the Korrys. All we got to do now is just an assemble, a solder, assemble, and an install. I want to show you just something on the back here. I'll see if we can see it. There we go, you can just see it. This little LED sitting next to the capacitor, I went and installed it per the silk screen. Look, the silk screen I believe is inversed. The flat edge of that silk screen isn't in line with the flat edge of the LED. So when I went and installed it and then powered it on, that LED is not going to light up. Maybe test it or bring up KiCad and check these things just in case if future panels are wrong as well. It's the only one that I got it wrong on. I'm not sure if it's the other panels I've brought up KiCad and looked at it, but yeah, don't make the same mistake as me. Just see the LED and make sure the orientation and the polarity of that is correct. Otherwise, it's a seamless build. Get the LED in, get the capacitors in, get your pots in, solder it all up, and then let's get into the install. The first thing we do with the install is test fit it. Don't start screwing stuff in and forcing things in if they're not going to fit. And the way I learned that was I realized the little registration pips on the blue potentiometers are on the wrong side. Now I got these from Mouser, so it's the legitimate part. I just think the 3D model might be slightly wrong. And that's okay, it's an easy fix. But how do I know where to put those little registration holes so they fit nicely? Because if you don't do it, you'll have an ever so slight gap unless you really crush them in there. So the way I did that was I got a little bit of red Citadel paint just because it was available. I dabbed it on the top of each post of the potentiometer. I then sandwiched it all together. I carefully removed it, and now I have 2 dots on my piece that I need to drill out. I'm going to get a 1.2mm hobby bit. I'm then going to manually drill that out. You can drill it all the way through. It's getting closed up anyway. And now you have the correct fitting part. You don't need to go edit a 3D model. You don't need to go reprint it. Just do a little manual tweak and things are good. Now that's all done, let's get back into installing. Remember, when you are looking at it from an upside down perspective, all of your push buttons are going to be reversed. Now use the PCB to help you with the orientation, and let's start pushing these all in. You'll see here on my mounting bits, or the bodies of the Korry switches, I've had to add little 0.5 styrene shims to them. For some reason, I don't know if it's a manufacturing issue on my part, or it is just the design that the tolerances are quite big. Maybe it's intended for FDM printing, not resin printing, but I just found my push buttons too loose. So I've gone and added shims to them, and now they're nice and sturdy and stable, and they've got a good feel to them. So have a look at that. If you do need it, either expand the 3D model or just add a little shim. No one's gonna see it, and you're good to go. Once that's all screwed in, we've got a singular screw holding it all together while we assemble the standoffs. And it's quite an interesting standoff choice. Threaded little rods instead of hexagon standoffs that we're usually using. It's not a bad choice. It allows me to kind of change the height of that. I don't mind it, but hey, just an interesting choice. Get 4 of these rods, and then there's no real height to doing this, just whatever works for you, go screw these 3 in, and then make sure you've got the ALE in the right orientation so everything fits. Best thing to do is have a look at the fusion diagrams and have a look at how it's built before you start assembling and getting the heat of it, in case you need to do something first. But hey, it's not a complex build, it is actually quite quick. And you can see here at the end product, we are using these SMR SMP connectors again to make it nice and modular. They really are handy. I went and bought 20 of each just because I know I'm going to be using these in future projects. I love them so much. So they really are quite cool. So while we're punching on, let's get into the ECM and let me show you how I got this really cool backlightable, NVIS compatible caution striping. So the first thing you got to do is get into Lightburn and load up our ECM front face panel, or the legend panel. What you can see is I've got blue for the cut layer, and then if we zoom in here, we can see yellow is selected for the scoring layer. Now remember, colors are just what I'm using. Any color is fine. You have to set the power and the speed, and that's, I know my scoring color is yellow, so whatever works for you and your laser, use that. But what we're gonna do is we're gonna score the paper, and we're gonna set it that it's powerful enough not just to score the paper, but to create a little mark line on the acrylic as well. So I'm using 16% power and 200 millimeters a second on my 50 watt CO2 laser. It's what works best for me. Once it's cut, you can see in our cut layers, it goes score first, and then it cuts it. The reason for that is I want it to score first, remain aligned, then cut it. You don't want it to cut out of the plastic sheet and then move ever so slightly and then score it, because you won't get that perfect alignment. Once this is done, we're going to take it, we're going to glue it to our diffusing layer, our light layer, which is 4.5mm clear, and then we're going to start taking away the areas we want to paint black. Now those areas are the black area and the yellow stripes. The reason for that is the yellow doesn't backlight. It's NVIS compatible, where it goes white, which would turn green, yellow, which would remain black under the backlighting situation because it's not backlightable. So it would go green, black, green, black, green, black. That yellow is not intended to be backlit. So that's why we're painting black first, we're masking it, then we're going to come over the top and apply the yellow color. So we've gone and cleared all the lines we want. We go and apply a good healthy coat of Rust-Oleum to it. I'm always doing 3 to 4, and then it comes time to masking up what we want to paint yellow. Because we scored the plastic at the same time, we didn't cut all the way through, we just scored it, I can now apply Tamiya masking tape perfectly to those lines, knowing I have that alignment. Then once that's done, we're going to apply a clear coat. I'm not using black and I'm not using anything else, I'm using clear, and I'm using Tamiya's acrylic clear here. Otherwise I generally use Mr. Color's Super Clear 3 or Super Gloss 3. And we're going to seal that tape in. Tape isn't the most perfect seal. It is for like general wall painting where you're not looking at the micro details, but when we're working on something as accurate as this, we want to give ourselves the best possible chance of no color leak. So we apply the clear, we give it a good hour or two to cure, then we go and apply light coats of what I'm using, SMS Trainer Yellow. It's the correct FS number for this yellow. And then we peel the tape off and it looks pretty good. And then we can make little adjustments as we go. And then we take it back to the laser and then we go and engrave all the text in. And it's a pretty tight panel. You can see we are skimming the boundaries of acceptability. It really is a tight panel. So make sure you do it accurately, do it carefully, take your time. You don't want to waste all that hard work. Then we get into the assembly of it all, and I made a couple of modifications to help me. And the first one you're going to see is I have 2 back plates here. The modification I've made is on the multi-position ECM switch. You will notice that the Open Hornet design only has a large hole. And if we go insert our multi-position switch, it's got a lot of play and there's nothing registering where 12 o'clock position is. So what I did was I went into Fusion, I downsized the hole, I applied a registration key, I've recut it, I'll upload those files as well. And now it slots in perfectly. I know it's perfectly aligned. Look, you probably could squash it down, but hey, I want it to be simple and I want you guys to have a pleasant experience doing it too. So we've gone and done that. But what we got to make sure we realize, because we've cut it out of acrylic, is there are 2 countersunk holes here that are going to have hidden screws in. Just get a drill bit, use something, countersink them out, and you'll be good to go. Now, while we're installing this back area, let's go install our switches and our multi-position switch. And this is the first time I'm using these orange back S3AL switches, whatever they called. I was a bit dubious of them initially, like knowing what a Honeywell switch feels like. If it's not going to meet that, I don't really want to use it. So I was like, hey, I'll buy a couple, I'll give them a go. And when I bought them and I just had them in my hand, they felt a bit grindy and not as nice. But once I've put them in the panel attached to the structure and there's the actual weight of the cockpit behind them, they actually feel pretty good. So if you're wondering if they are worth it for the money, yeah, they are. If you don't want to go and buy them all, that's fine. Do it on the ones that you're going to be using a lot, such as the dispenser. Did you need to do it for the OG switch? Meh, who knows? Probably not. I don't use this as often as I probably should. Definitely use it for the battery switches, anti-skid switches, anything that you're using a lot. Go and spend that extra little money. You will not regret it. Now that we've got our switches installed, let's get into installing the Jet Select switch and its mounting bracket. Now that's installed just by, same way as the Korrys, same methodology, especially with the Jet. I'm not blacking that out. I'm waiting for that to be backlightable. And then we're going to go install it onto the structure. It uses 2 small screws and 2 small nuts. If you look at the documentation, it calls for 2 really small self-tapping screws to come in from the back of the panel and screw up into the resin. Now those holes aren't included on the PCB. Now I thought, hey, is this one of these moments where going with a different manufacturer than what was recommended by Open Hornet be a problem? Turns out it wasn't, because if we look here at KiCad, those mounting holes that should be in the corners here actually aren't there at all. So there's just your 2 mounting holes for your little threaded bolts and the nuts to screw it down. And hey, even with those two, it's perfectly stable. And then we've got it all done. Then what I did was I didn't go and rush to install our top plate with that really nice paint job. The reason for that is I'm going to be flipping this around. It's going to be on the table. I don't want to damage that paint job, and we can leave it till the very end. But what we are going to do is we're going to flip it upside down. We're going to start the back engineering of all the wiring, and we're going to install the standoff just like the RWR. It's not too hard. But I want to show you some modifications I've made to the wiring, just like we did with the vid control, because modularity and ease of maintenance is important for me. If we look at the interconnect, we're in the same page 3, lower instrument panel, but we're a bit further towards the right of the page. We can see the ECM dispense section, and then it's got its ALE and respective connectors. If we look what the ECM dispense is looking for, it comes out of P4 connector here, which is plugging into the ALE, and it connects into the ECM jet switch. And then we've got another one of these SMP SMR connectors, but it's an 8-pin one this time. And it connects the ECM multi-position switch, the dispense bypass off switch, and the auxiliary switch as well. And then it's got a singular ECM ground. That then, if we project it a little bit to the right, and this is how it connects with its SMR receiver. So what we're looking at is very similar to the vid control, where we have 3 switches going into one singular port. If I want to replace one of these switches, I don't want to have to try to take apart all 3 just to get ease of access. So what I've done is I've broken them out into a 2 SMR, a 3 SMR, and then a 5 SMR. These all connect straight, so we are bypassing this 8V connector, the 2, the 5, and the 3, and the 2 again. They're all going to the header pins, which are fine, but I plug them out into their own SMR cables. That way I can remove that switch from the system without needing to remove everything. Don't have to, it's just an easy way that I've found doing it, and it kind of looks a little bit neater, and I can just go unplug this one, and we can go take that switch out of the system, not messing around with any of that wiring. Especially if for some reason we mess around, we desolder it, we shorten that cable, we don't need to recrimp it all. So they're quite nice. And that's kind of it. Let's go and install it. I'll show you here what I found, and then I'll show you how I fixed it. And the easiest way to look at this is if I bring up a Fusion document, just because trying to get the correct camera angle on this is going to be a nightmare. If we look at Fusion, we can see that the ECM panel here is resting on its PCB. The PCB doesn't recess into the structure. That's fine, that doesn't bother me. But what I found was, and don't make the same mistake as Scott, when I went and screwed these down, because there is nothing supporting that acrylic underneath it, I screwed down too hard and I cracked the acrylic, needing to remake a new one. So what I've gone and done is I've gone and created these tiny little PCB thickness. Now, if you don't know what the thickness of a PCB is, it's 1.6 mil. 1.6 mil little washers that are going to go under all the elevated platforms. That way I can really screw it in nicely, because if we are using these lockable switches, you want to know you can pull and push on these as much as you want, and it's going to be secure. So let's go and install these. This is probably now the easiest way to do it, is fit them one at a time and then just maybe 2 threads in, give it a screw in just to hold it. But yeah, we'll give this a go. And I recommend technique only, don't lock it down off system just yet, because you've gotten most likely 3D printed this. If it was aluminium milled and it was nice and strong and solid, different story maybe. But this might have a bit of bow to it, a bit of flex. When you go and put it into your cockpit, it's going to have its new shape that it wants to adopt. If you've gone and locked it based off the shape of an acrylic piece, it's going to put pressure on that. So let it be there so you're not damaging it, but go install it into your cockpit, then go and tighten everything. Once it's in its final shape, you're going to get a better fit and you're not going to get the creaks and the possible cracks. There we go. Lovely. And there we've got it. That's us done. 2 very cool modules done. Now it's time to install it and our lower instrument panel is done, other than the track actuator and the USB. But for the purpose of componentry, ABSYS cabling, and being able to cable manage the whole thing, we are ready to go. So let's head over into the next room. That's where the sim is. Let's go and install it. And I'm thinking we're gonna have to drill a hole through this wall to be able to pass USB and HDMI through, because I don't have a second computer to run that sim there. So we're gonna be like a little mouse hole, and we're gonna start passing cables through in the next couple of episodes. Alrighty, let's go and install these panels. We're here in the sim room. Give yourself a nice amount of room to do this, especially for the construction phase. What you don't wanna do is give yourself a tight amount of space. The first thing you're gonna do is probably knock something and break that piece. The second part is you're probably gonna hook your back on something. You're probably gonna hit one of these corners, you're gonna hit your head. Give yourself space, and you don't want to pull a muscle doing a hobby. Fun fact, physio is probably more expensive than the panel you're trying to install. So if you are going to do this in a tight space, put physio in your health insurance. Other than that, let's get rid of this UIP. You're going to need to remove the UIP first, because some of these top screws to get the IFEI in require the UIP to go. The next step is when doing this one. Now this may be the first panel that you're making, right? If you haven't followed along in the order that I've been doing it, that's okay. Just know that you're gonna need to put the AMPCD module in first before you can put any of these side pieces in. The reason for that is there are 2 screws on either side of the AMPCD that get fouled when you go install these. So if you're installing for the purpose of storing it, that's fine, but just know you are going to need to unplug it when you go put your AMPCD in. So that's all sorted, let's go and get this installed. Now you can see I've already got the cabling ready to go. I've already test fitted, I've done all the looming, things are looking good. I'm gonna see if I can put a couple of pictures now while I screw this in of what that underside cabling looks like. And I think it looks pretty good. Now remember what I said about the jet select panel? You don't need to do it fully, you just need to have a little bit. It doesn't have to completely come out, but yes, you will need to loosen it to be able to get your screws in. And what you would have seen me do there is I loosened the 4 screws around the IFEI, gave it time to flex. I heard it crack, which meant like some of that like tension is releasing, which is nice. And now it's in its final position. Just go and screw it back in. There we go. That's pretty good. Got a good little feel there. Next step, we are going to install the ECM. Now this is one of the tricky ones. Make sure all your connectors on the bottom here are ready to go. It is a nightmare getting behind there. It's doable. Again, we're gonna move this then to this side, and we're gonna give ourselves space. We're not gonna pull a muscle prior to Christmas. Now, I've got most of these interconnect wires. All we need to do is have an ABSYS plug into there and an ABSYS plug into there, and they are these cables ready to go. So when you're installing this, it's a pretty tight fit. Can I recommend this lower vent panel, leave it loose. If you can, leave this loose as well, but I know that this fits because it fits over the top of it. But the big one is this black little bit of trim. If you don't install the AMPCD and this all together, now I've gone and test fitted this, that's why I'm not doing it that way. But when you do it the first time, leave everything loose, get it into the structure, and then go and screw it in. So, there we go. Lovely. Again, screw it in a pattern. Don't just hard lock one of these screws in. I'm sure someone in your life has taught you how to screw screws in. and the nut will fall out. But hey. Do you know what you could do? If I wasn't being lazy, put a tiny bit of tape over them. It'll hold them in nicer. But hey, we're gonna be lazy. Okay. Don't be like Scott. And then if you really hate the look of the tape for some reason, you can just pull it off once it's installed. Okay, now we're going to go tighten these ones up, like we said. And that feels way better with those washers on, just from my opinion. I'm quite happy with them. Lovely. Re-secure the vents. And that there is looking pretty cool. What a fun project. This is the UIP done. We've got the linear track actuator coming for the rudder pedals, but that's going to be the very last episode, just so I can keep flying DCS and flight sims outside of the pit. The USB hubs are coming, but all the wiring's done. At the end of this, I'm going to show you some B-roll, and it'll just be this as a complete module. But hey, very, very cool. Now you've got the weight of the pit. Pulling on these are just so nice. Good force on the push buttons. Can't complain with that. Yeah, still up in arms, deciding if I go that anti-glare look or I just leave it shiny. Regardless, I think it looks sick. The Open Hornet team has done a wonderful job designing this, and it's pretty straightforward. There's only been ever so slight mods that I've done purely for ease of filming it on the camera for the YouTube channel, or just me being a little OCD. But hey, what a cool project. I hope you enjoyed episode 30. We're steamrolling now. Episode 31 and 32 are the UIP. Then we go left and right consoles. We do the seat, we do the stick. And then the final reveal will be doing a computer system. But if for some reason you guys have questions, you want me to do something extra, just let me know. We can always add it into the episode list. But in the meantime, go enjoy some flight simming. As always, stay safe. Enjoy your Christmas break if I don't see you before then. Have a wonderful rest of 2025, and I will see you in the next episode.